They are snails, a little bit bigger than these things. So they're big. When they say giant African land snail, they do mean giant. They're like this big. And like a for real snail that will like. They're big and slimy. So there was a little kid who went to Africa and came home and brought home some giant African land snails because they're cool for a little boy in the 60s to bring home the gross slimy blood. And then his grandma decided, I'm done having these dang on slugs in my house, and put them in her garden. About 7 years later, there were 18,000 of them in the Florida area. So, what we're asked to do first is we're asked to figure out the equation for how these things grow. What do we know? What you got, Cameron? That is I see 100% why we're thinking that. We have 18,000 of them. Is that how many we started with?
Oh, no, that's what it is.
That's what we ended with. So that's going to be our, A in this account. I just had to lighten that a little bit. So we typically think about exponential functions with our A equals P. We might have our base to the t, it might be like this, or we might have our p1 plus or minus r. There's two different ways of thinking about this equation to the t. So we know that that 18,000 is what they have eventually, the total that exists. So our 18,000 what did we start with? What is our P, our initial population? That's what we wound up with. The little kid did not bring home 18,000 snails. He brought home 3 snails. He snuck those 3 into his suitcase and brought them home. Do we know what we're growing by? How quickly the snails grow? What is the other piece of information we have about snails? It was 7 years. So we know the time. We are asked to figure out how quickly they multiply. We want to know what this multiplier, what this growth factor is. Because that's what this B stands for, is that growth factor. So we want to figure out what this base is. But we know it's a power of 7. So that gives us kind of a start, but we'd really like to figure out what that growth rate is or what that growth factor is. What can we do to try and figure out what B is here? Divide both sides by 3. Excellent start. If I divide this side by 3 and this side by 3, that 3 and that 3 cancel out. So we get that 6,000, because 18,000 divided by 3 because it's 6,000. We have some base to the 7th power. The heck can we do there? Yeah, it's really much like if we had b squared, we would take the square root. If we had b cubed, we take the cube root. So we have b to the 7th, so we're going to take the 7th root. We want to unpower the 7. So when we're doing that in our calculators, there is a button for it. I'm going to show you where it is in just a second. I'm going to have to take a second to open things. So to get rid of this 7th power, we have to take the 7th root of our 6,000 to figure out what the heck this base is. So let me get the calculator up so we can do that. I'm going to show you how to do this. This is not going to be something we have to do super frequently, but it is something that's going to be handy to know if I don't knock over all my flowers. There we go. It's coming. We're not doing logs. So if we want to take the square root, we would typically come here above the square. So like if we had 4 squared, I could then do my square root to get back. So just like we have our any exponent button up here that I could take my 3 to the 8th or whatever and type in any exponent I want, if I want to take the 7th root or the 3rd root or any root, I can put in my front number. That would be it's called the index. You hit the green button and the any exponent button. Just like with squares, we undo it by hitting the green button and the square. To undo any exponent, we hit the green button and then the any exponent button. So we can type that in. Our 7th root of 6,000. And this is going to give us, for the most part, what that base is. 3.46526, blah, 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 blah. Let's take 3 decimal places and call that good. 3.465. 3.465 is our base. What this piece is the growth factor. We talked about that a lot last week on our growth factor versus our rate. This is our growth factor. It is the chunk that's going to have the power to it. Thanks, Matthew. So our kind of generic equation for how this would happen and how many snails there's going to be for some number of years t, we would have some amount of snails is our starting amount. We still start with 3. But now we know what it's growing by. It's growing by that 3.465 to the t. So if I want to know how many snails there were in year 2, I could find that out. If I want to know how many snails there are in year 50, if they never did this and the world was just taken over by giant African land snails, we could do that. That would be an absolute metric ton of snails, at least. And so it would be a lot of them. So this gives us our growth factor. This isn't a really important piece that's going to come up in formulas we use later on. This is a very, very, very important piece we will probably see repeatedly later on. We might want to pay attention to what a growth factor is, because this will come up in a couple of formulas we use later. All right. So what I want you to do is I want you to look at B and C and see what we can figure out. See if we can figure out what the percent is that it's changing by. So that would be if we wanted to write it like this guy up here. See if you can figure out how much it changes per month. So we got here, this is how it's changing per year. See if we can figure out how much it changes per month. So look at B and C. I want you to give those a try. We're only working on this page today, so I want you to try on those. The downside with you having to try is you are going to have to actually get out your workbooks and, a writing utensil, because this problem is unfortunately not on TikTok or Instagram. So it's not on your phone. Okay, so give it a try. Look at B and C. See what we can come up with. I'll leave this one up here for a little bit so you can see it. You can use this kind of as a structure to go with. We did our 7 years. We had our 18,000 total. See if we can figure out how it's going per month. You can do the exact same process. There are other ways about it, but that is one of the ways you can do it.
You gotta catch her when you can. Oh, and Camilla got no more kids. Send me. Thursday.
Bro, please hit you up. I'm just so bored of playing with trash. We got no last night. Can you have squad now? How long can you have for? There's there's a mode you can play 433. It's like dummy reality. It's not real. Revenant or Ash, to be honest.
Revenant? Revenant was my name. But I don't know how to use them now.
Huh?